This is part 2 of problem 140. I was having issues with the video, so I uploaded it into parts. Okay, now we're back here trying to solve for r dot and v theta. We know that theta is here, and so we can move it to this angle and define theta there and theta there. Now we can use trigonometric identities to solve for the values of r dot and v theta. Let's do r dot first. R dot is equal to negative v cosine theta, and that equals 100 cosine of 43.2. When you simplify that, you get 73.0 meters per second. And that is the value directly for r dot. On the other hand, v theta solves for the way to get to theta dot. And that is 100 sine of 43.2. And when you simplify that, you get 68.4 meters per second. So remember that this is v theta, not theta dot. To solve for theta dot, we'll put in the v theta over r, and that is 68.4, 21,900 meters. In the end, you get that theta dot is equal to 0.00312 radians per second. And the small value is okay. The angular values are typically fairly small, especially when they're in radians rather than degrees. Moving on to acceleration. Acceleration is done in a very similar way because we know a normal and we know that a tangential equals 0, so we're not even going to put a tangential in this figure here. And the r-axis is there, and so AR is parallel and A theta is perpendicular. The acceleration vector is made up of AR and A theta. And the components of these are going to be the equations that we use. And r theta double dot plus 2r theta dot. So this on the left side is acceleration along the r axis, and this side is the acceleration on the perpendicular axis. So let's do AR first. AR equals negative a sine theta, and that is negative 3.33 times sine of 43.2. In the end, we get that it equals 2.28 meters per second squared. We still need to convert that to r double dot, so we'll plug in this left side of the equation and have this equals r double dot minus r theta dot squared. When we solve for r double dot, you get that r double dot equals negative 2.07 meters per second squared. So now we have calculated that part. The only thing we have left to do is calculate theta double dot. And we'll do that exact same thing with theta double dot. Negative a cosine of theta, and that equals negative 3.33 cosine of 43.2. And simplified that down, you get 22.43 meters per second squared. We still need to convert that to theta double dot. So on that right side of the component here, you get that a theta equals r theta double dot plus 2r dot theta dot. And we will solve for theta double dot, and you get that it equals negative 9.0110 to the negative 5 radians per second. And once again, it is okay that the value is so small there. So now we have converted from velocity and the indirect value that they've given us of a normal to values along r hat and the angular values that are